In today's video, I will show you this odd chemical I found in my attic called potassium chlorate. This chemical with the formula KClO3 is commonly used as a herbicide and a strong oxidizer. In a few moments, I will show how powerful of an oxidizer this is. To give you an idea on what is an oxidizer, let's ignite some wood shavings. This pile of burning wood shavings is a classic redox reaction, a process that is naturally exothermic, releasing energy as heat and light. The carbon in the wood acts as the fuel, giving up its electrons to the oxygen in the air. At 21% concentration, atmospheric oxygen works remarkably well as an everyday oxidizer for standard combustion. Now, replace the air with chlorate. Chlorate carries its own oxygen trapped right inside its crystal structure. That creates a vastly denser source of oxygen, forcing the fuel to consume its electrons and burn exponentially faster. As you can see side by side, you can clearly tell that chlorate acts as a much more dense oxygen source than air, and therefore makes the wood burn faster. Switching to a different fuel, heating sugar up would just simply caramelize it. This is unlike wood. Sugar simply melts under heat instead of releasing flammable gas like wood. Similar to the wood, let's add some chlorate to see if it have any effects on burn speed. But before we do this, a fair warning to never repeat any of this experiment, since chlorate mixtures are notoriously heat and shock sensitive when mixed with organic matter or reducing agents, and will violently detonate it when given the opportunity. Now let's see if adding it will make any difference. And voila! Finally, the sugar can use its stored energy in a spectacular display. I made a second batch in which I now mix the sugar and chlorate in stoichiometric amounts, allowing it to unlock its full potential. Now, surprisingly, this mixture is not really shock sensitive as I thought it would be, but I would not advise you to use this as a nitrate substitute for rocketry. Though there is one thing I can agree on, and that is how beautiful the lilac flame produced by the potassium ions in the potassium chlorate. Now for our last experiment, by far will be the most dangerous, since we will be making chloric acid. This acid is made by treating any chlorate salt with concentrated sulfuric acid, forming the free acid. Unfortunately, chloric acid is unstable and will decompose at elevated temperatures into chlorine dioxide, which is shown here as both the reddish liquid in the jar and the green gas escaping from it. This gas is a potent oxidizer that can violently react with organics, and also a potent explosive by its own. So I advise you not to make this in any conditions. Now let's add a cotton ball from a safe distance to see on how strong an oxidizer this mixture is. Now I wish I could tell you on how loud and violent this reaction is, since this gave me tinnitus instead of several car alarms. Look on how violent this acid is. Even though the cotton ball had been vaporized, the heat of the reaction heated the acid so much it causes more to decompose into chlorine dioxide, causing violent bubbling. The only lesson we can learn from this short video is that chlorates are stupidly strong oxidizers and should be treated with respect. I hope you like and enjoy this experiment so you do not have to do something as risky shown here.